Today, I'm not here to solve some equations. I'm here to explain about why this equation works. Actually, this equation is really important when you work on some questions about limits of trigonometric functions. So it's better to memorize this function. But to use it, it's better to know why it works out. Why it works. So let me explain about it. So to prove this equation, we are going to use the squeezing theorem. Do you have any idea about it? Actually, in my previous video, I explained about squeezing theorem. So please check the video out as well. And okay, let me simply explain about it. Squeezing theorem, if you have unknown number, for example, a, if you know the inequality of this number, for example, if a is bigger or equal to 0, and if a is smaller or equal to 0, a is going to be like 0. This is squeezing theorem. So let me use it. But before using it, let me just, oops, it's so ugly. Let me just draw some shape. This is circle. This is kind of ugly though. Okay. And this one is right angle. Then, yeah. Then what I'm going to do is to compare the area of some shape. Yeah. For example, the first one is this one, this triangle, and second one is this one. Okay. Then third one, let me use the other color. This right triangle. Sorry to mess it up, like so many colors here, but let me compare. Of course, you can simply compare the, okay, this triangle is smaller than the blue one, this one, and this is also smaller than this red right triangle. Let me just use the formula to calculate these area. Let me put this one as theta. The area of the orange triangle, let me put the radius is r. It's going to be 1/2 times r square times sine theta. Because you can just simply, if you have triangle like this, you can just simply calculate the area using 1/2 times radius times sine theta. Okay. Then in the middle one, it's going to be 1/2 r squared theta. If you have no idea how to calculate this one, just leave me the comments. I will explain about why it's going to be like this. And red triangle, it's a little bit, it's not too complicated. Okay, this one is r, then theta. So this one is actually r tangent theta. Okay, so this is just simple, just regular triangle. 1/2 times r tangent theta. It's going to be 1/2 times r squared tangent theta. So far so good. Then what I'll do is we can just cancel out 1/2 for everything, and also r squared. Then now it became like sine theta tangent theta. We can still cancel out something because this is cosine theta, sine theta over cosine theta. So we can just divide it by 1 over, we can multiply 1 over sine theta for everything. It's going to be 1 theta over sine theta and 1 over cosine theta. Is it okay so far? Then let me flip it for everything. If you flip it, the order is going to be different. Oops. Let's change the top and the bottom. Okay, I flipped everything out, so the order became completely opposite. Then the equation was like this. Let me back to the equation like this. Limit as x approaches 0, sine x over x is equivalent 1. So let me find the limits of this one. Limit as x approaches 0, cosine theta is, which is 0. Yeah. So, oops, sorry, I made a mistake. It's not 0, it's 1. I'm so sorry about it. It's 1. So this means by the squeezing theorem, limit as x approaches 0, sine theta over theta is going to be 1. Because this one is going to be 1 and this one is 1. So yeah, you can use squeezing theorem now. That's how you can prove it. Okay. So for the next video, I will explain how to use this one. That's it.